Well, hello everyone, and welcome to the next episode of, well, actually the first episode of this new kind of series that a mini-series really, about me, a to-be astronomer, reacting to flat earthers apparently misunderstanding pictures from the Webb Space Telescope, the James Webb Telescope, this time by the somewhat more famous DITRH. And let's see what they have in store for us this time. I will mention that I have actually seen this video to about the 1 minute mark when I remembered that my microphone didn't record any audio, so I will be starting again.
But this, Tosh, is just computer-generated imagery, CGI.
This, by the way, is a picture from the James Webb Space Telescope, which, in the strictest of senses, it is, because it's being recorded by a computer. The CCD chips and the CMOS chips are connected to the flight computer of the James Webb Space Telescope, which then send the images back to us. So in the strictest of senses, it is computer generated because it's measured by a computer, or by the CCD chip that is connected to a computer, really.
To get people, again, to go along with the fantasy.
It's such a lazy response now, isn't it? CGI.
It is a very lazy response, because it's just dismissal, right? It is like, it looks fake to me, so it has to be.
Here, CGI there, without any proof to show how you think it's computer generated.
So what at first I thought that was going to happen now, which apparently didn't, because again, as per usual, I don't know what is shown in this video. I look at them blind or semi-blind when my microphone decides to strike again. So the thing that's going on is that apparently they just show a bunch of pictures, some of which are not made by the James Webb Space Telescope, and I don't know yet which bigger point they're drawing to, right? But I hope I will figure out. And that's not a picture from the James Webb Space Telescope. You can actually, it's very easy to see why. First of all, you have those things there that you can see, that you also could see with the James Webb things. Those are called diffraction spikes. Those are because the light is diffracting and reflecting off of some struts of some structure that repeats on the center of the telescope, right? With Hubble images, you always had these huge diffraction spikes where actually the struts that were holding the mirror in place were refracting. And with the James Webb Space Telescope, you have these because its mirrors are in hexagonal shapes, and things are slightly refracting differently from the edges of the mirrors, and that's why you get these weird patterns there. Note that you only get these patterns for very bright stars, and they always look in the same direction, right? You don't get these for galaxies, by the way. You only get them for bright stars. That's something to keep in mind throughout this video. Because here, they are going everywhere. This one is the same as this one, which is the same as this one, which is the same as this one. With diffraction spikes going absolutely everywhere. You have these weird small things that all also have diffraction spikes, but these diffraction spikes look different from the other ones, so they cannot be originated from the same telescope, so that's complete crap. Then you have weird white circles in the foreground, because why not? White circles are everywhere in space, I guess. Complete nonsense. And then you have, with the same exposure setting, which is somewhat difficult, you also get a nebula. And something that I think is a comet? I don't know. That's complete crap. That's not an astronomical picture by any stretch of the imagination. I will later show what astronomical data actually looks like. And this one, in the original video, I laughed a lot when I saw this one, because this is so amateur, the clear work of amateurs, right? You can see stars that have 5 diffraction spikes everywhere in the background, and then you have these. Those were almost made in paint, probably, these stars. And then you have again a nebula, and you have stars with diffraction spikes in the nebula. It's come on, people. This is made by someone who has absolutely no idea what they're doing. Also note how the diffraction spikes don't always look in the same direction. That's not possible. Oh, and there's the comet again. Or at least I think it's a comet. Might be something else. And now we have one that's more akin to the first one, and I noted that here you have these funny things again, whose diffraction spikes just go anywhere. Then you have the Orion Nebula here, stripped of all color and turned yellow. It's actually mirrored over here, and I believe it's in here too somewhere. Then you have another nebula up here, which for some reason has color. This one hasn't, because apparently that's how that works. Usually in astronomy, we don't make color pictures. We take pictures in different spectral bands, right? So we take one that's only red. So we have a red filter, and then we record the black and white image that we get. And if it's white, we know that there has to be a lot of red. And if it's black, we know that there's no red. And we do that for a whole bunch of spectral bands. And the images that are sometimes printed, like in magazine and stuff, those are put together by the computer, overlapping with the different colors, because actually the astronomer cannot do anything with color pictures, because we want to measure fluxes. And in order to measure fluxes, you need to deconstruct this thing into its colors. So we even photograph it in these different colors, because if you have a filter and you know the photometric properties of this filter, you don't need any software assistant decomposition of a color picture. Then you can just know, well, with this and that filter I got such amounts of flux at this star, and then that's your value. We don't actually have color pictures. So even the pictures that you get from the James Webb Space Telescope that are shown are actually pictures that are being overlaid. They are kind of a composite of many colors. In German, we call those Falschfarbenaufnahmen, or kind of wrong color observations, because they are actually not the color that we later on ascribe to them. This is just made for popular scientific purposes, usually. And also not done by the astronomers themselves, usually, with some exceptions. I've made some myself because they look nice, but you know. Also, what's going on here? Just wondering. Okay. That's getting interesting. This is a real picture made with James Webb Space Telescope. You can tell because you have some stars with diffraction spikes, right? But the smaller they get, the less diffraction spikes you have, and in the background you have galaxies that don't have diffraction spikes. In this case, you have foreground galaxies, actually a couple of them. This might be Stephan's quintet, I'm not sure. So that seems like a genuine James Webb observation to me. Genuine in the sense that, again, it's colored in after the fact. I will later show you, as I said, the actual astronomical data. This is again a wrong one. Do you see how the stars again look super strange, and this nebula is very colorful, but very wrongly colorful. Why is there such a stark separation of emissions? That does not make sense. Now, this one is interesting. This one, I mean, it's not a James Webb picture. There are some funny diffraction spikes going on up here. This might, however, actually be an astronomical observation, just not with James Webb. I'm unsure. It's definitely not a science one. You can see that some of the stars here are very liney, and they somewhat align. This could be an amateur trying astrophotography and not quite having the settings figured out yet. Yeah. It's definitely not from James Webb. Definitely not from James Webb. Ah, there we go. There's a James Webb again. Again, you can see because you have the diffraction spikes the right way. You have galaxies in the background that are not just white blobs. I believe that's what the white blobs are supposed to be. You have gravitational lensing that you can see very clearly here. That's a nice picture, actually. That's probably from a deep field. Do we even need to talk about this one? Look at the stars. It's ridiculous. Ah! So yeah, so they show us how they made these, and very little surprising that they look the way that they look. I would argue that every astronomer who has worked even a rudimentary amount of time with a telescope can tell immediately that those were fake. And the funny thing is that I very much believe that they are being cool, like showing something off here, which, you know, no. Because those pictures are crap. Also, how do they think that astronomers work? We make a picture and then that's that? The picture we really don't care about. We really don't care about. That's something that popular scientists do after the fact, right? What we do is we look at which stars those are. We do statistics with those stars. We plot their, for example, luminosity to their color. And things like that. Not just superficially looking at them and going, wow, which again underlines their deep misunderstanding of what's actually going on in astronomy. But I'm a little surprised they would not be flat earthers if they understood what was going on. Yeah, you see, the very big difference here is that a lot of people can kind of steal together some data, but that's completely arbitrary because it's not real. If I were to try to figure out, because there's no data behind it, if I were to try to figure out which one this star here is, it wouldn't work, apart from the fact that you have 3 Orion nebulas in there, you know. Absolute ridiculous. It's a joke. As I said, you know, so I identified these two as James Webb very quickly. The others as fake, apart from, as I said, maybe that one, that definitely wasn't the James Webb thing, right? It was apparently also made with this one, because I just see that it's the same nebula as that one, but this one is somewhat believable with someone doing poor astrophotography, right? But the other ones are completely ridiculous. And I will show you why in a bit. Well, not solely, it also does other stuff, but it is definitely a space agency.
It's such a lazy response now, isn't it? CGI here, CGI there, without any proof to show how you think it's computer generated.
Well, but Simon Dan, which is the one talking in the background here, is still correct. You don't present every evidence, and you were absolutely, fundamentally incapable of faking James Webb pictures. You know, so, and you would need to fake all of the data behind it too, which is quite a bit harder.
So you'll want to go to nasa.gov/webfirstimages. You'll want to download the 28 megabyte photo. Then you'll want to open it up in software that lets you see the metadata. This is similar to how the GPS.
I'd like to mention here that astronomical observations don't come as JPEGs. They come as what's called a FITS file, right? And as soon as you have it in a JPEG or some other kind of classical image data type, if you will, it most certainly did not come from the telescope directly. Someone has done something with it already. There are some data that directly comes from a FITS file, but a FITS file, .fits, is really kind of weird data format that mostly only astronomers use. So, you know,
this location is stored to the photos on your phone. Now, the important thing is that you'll be able to see that it was created in Adobe Photoshop.
Because it's a wrong color observation, as I mentioned earlier. They take all of the colors, the red one, the green one, and usually the blue one, and they overlay them to make color pictures, because astronomers don't care about color pictures.
But the best part is you'll be able to see that the graphic designer started on July 3rd, and he finished making this fake photo on July 7th. So it only took him 5.
Well, it's not fake. Again, it's you know, composed image of many different colors, right?
5 days to create this fake photo, and that makes sense. You can go on YouTube and watch tutorials on how to make these photos. It's actually very simple. Now, if you want to fact check this, you'll want to copy the URL, paste it into some third-party photo forensic software, and let's just wait for it to load. And the reason I'm doing this is because I care about you guys. I'm not sure if it's just like a mental health issue or...
That's also not the ITRH. Because the guy in the beginning definitely wasn't the ITRH. That's also not him.
It's actually like a spell casted over you. But the same people who believe these photos are real are also the same people who believe in COVID, who believe in climate change, who believe in vaccines, who believe in Ukraine. And you're in a...
Okay. It's you know, things are getting serious when they mention all of that, but you know.
To the world. You're actually part of the problem. Okay, so once it loads, you'll want to go to metadata.
Says the problem.
Now scroll down and you'll be able to see the exact same thing that I showed you before. Made in Adobe Photoshop 2022. You can see the color profiles, all the editing that's been done, and it's completely fake.
It's fake in the sense that this is not how it really looks. You have, for example, here you have the instrument that it came from. So they took 6 pictures from the near infrared camera, and they ascribed different spectral colors to it. That's exactly what I mentioned. Just here they did it with 6 pictures. We usually do it with 3.
So the best argument you can put forward is that this is a composite photo. Someone combined many photos into one, and they're not showing us the original photos for whatever reason. But what
because
I
they are
fucking
uninteresting.
Did not come from the James Webb Telescope. None of them did. They all came from Adobe Photoshop. So the question is, why are they not showing us the raw, unedited original?
Do you all want to see the raw unedited ones? I'll show you some of the raw unedited ones. Not from James Webb because I don't have access to them, but from I can show you Hubble. No, I can show you Galax. I did my bachelor's thesis with a bunch of Galax data. I can show you Galax. Hang on. So here I've started some of the software that I use. I used for my bachelor's thesis to get the real data. This is just the data from the satellite. In this case, it's Galax. That's the Galaxy something observational satellite. It was the Galaxy Evolution Explorer. That's the name. It was initially used to look at galaxies in the ultraviolet. It was later also used for some stars. That's what I wrote my bachelor's thesis about. And this is what actual pictures look like. They look like fucking crap. Sorry for the swearing. The thing is, here you have regions that were never observed, and these have usually this blue in this. This is called Aladdin. That's the software astronomers use. It's this kind of blue thing. That's the background color for regions they didn't observe, and it's not properly calibrated yet. You can see that because you have those things in your data. You need to. That's actually when they made an observation here, and they changed the settings until the next time, because you can see the borders here, right? You can see this. Wait, let me. Oh, yeah. So you can see the borders here, which is that's the kind of data that I have to deal with, for example. So that's why usually you are not being shown the real data, because the real data is shit. Also, you can see things like, oh, sorry. You can sometimes it's hung up on me again. The Galax satellite really doesn't want to load in sometimes, and this appears to have happened now. Let me quickly. Oh, no, it's loading anyway. Don't know what that is. Might be a galaxy. That's there. That's a nebula, for example. Do you see how that's very unappealing to look at? Could also be a galaxy. do you see how that's really unappealing to look at? Like from a visual standpoint, imagine having that on top of a magazine. I actually want to find out what it is now. Ah, it's a galaxy, okay. Because actually, when you hover over it, you actually get to see which galaxy that is, which I imagine you cannot do with the pictures that you faked, right? But faked extremely poorly, and so that's what real astronomical data looks like, right? And you're not being shown because look at it, it's hideous. Until you get to see that, there's so much been done with this data so that it's appealing for the layman, because at the end of the day, that's at least the line of reasoning that we are being told in university. At the end of the day, the taxpayer pays for the stuff that we do, pays for the stuff that I do. If you live in in Europe, for example, you are contributing that I can get the data I need for the master's thesis that I'm currently writing, because I am getting this from the European Southern Observatory, which is contributed largely by the members of the European Southern Observatory, which are a whole bunch of European countries, not all of them, but a great big number. And actually, you have color compositions right inside of Aladdin here, where they overlaid the two, the far ultraviolet in this case and the near ultraviolet. And if I load that in, hang on a second, is it that one now? It is not. Why is it not? I'm sorry. Ah, now it is. Okay. Yeah. when you overlay it, one of them is going to be red and colored in red, and the other one is going to be colored in blue, and that's when you get those funny things, right? And these abominations, of course they don't put these on magazine covers. Why would they? Who in the right mind would do that? So what we do is we work on it, right? Well, some astronomers work on it and they try to really get into things. Although I would argue that objects like that one could already be seen rather nicely. This is one of the objects I did one of my the bachelor's thesis in, because it does interesting stuff. Because when you look at it, you can see that there's kind of a bubble around it. And that's not one of the observational bubbles either. It's just doing funny things, and we are getting, yeah, there we go. The star has kind of a bubble around it. That not important. And that's the reason why. So yeah, it's if flat earthers I'm directly addressing all of the flat earthers. You could. It's fine if you do all of these videos, right? That's cool. I mean, it's not, but you could at least bother asking someone who actually knows what they're talking about. Just bother. Because if you ask an astronomer, he's going to explain it to you in 30 minutes, and then you won't do these videos. And the only thing that this video has shown is that you do not care whatsoever presenting feasible any argument at all. That's the first thing that you've shown. And the second thing you've shown is that you really don't care about it either. Almost as if you're just interested in putting a narrative out there. Which I find sad, really, but enough of that. And with that, I think we're done for this time. If you enjoyed the video, maybe consider leaving a like, or dare I even suggest subscribing. Other than that, I will see you at whichever video I stumble over next when I look at that. And yeah, until then, I hope you're having a nice time, and goodbye.